Everyone here has known someone who has suffered from cancer. In my immediate family, 2 people have had cancer. Both of them had the chemotherapy treatment, which involves injecting chemicals which usually kill cancer cells, but can also harm our own bodies. This treatment is quite toxic. However, what if we could change that and create a new treatment that targets cancer cells more effectively than any other solution? I think that's possible, and I think that nanoparticles are the solution. If scientists were to focus their development around this solution, I think that one day we would be able to remove all of the harm that is bundled along with cancer treatment. Now you may be asking, what the heck is a nanoparticle? A nanoparticle is a tiny capsule-like object that carries cell-killing chemicals called inhibitors. Whilst chemotherapy might harm a range of different cells, nanoparticles are covered in small structures called peptides. These only latch onto cancer cells, and thus only the cancer cells receive the inhibitor inside. Therefore, in using nanoparticles, we are able to kill cancer cells without harming the healthy ones. Nanoparticles have been proven to be very efficient at targeting specific types of cancer cells. Now, this has been shown in a recent study involving a type of lung cancer. Nanoparticles were taken and were loaded with an old chemotherapeutic chemical called paclitaxel. When trialled, this solution prevented 14 tumours growing in 15 subjects. This is impressive by itself, but it's even more impressive when you consider that, collectively, the nanoparticles had 100 times less paclitaxel than someone would normally get through chemotherapy. Now imagine all of the chemotherapeutic inhibitors that could be improved on if they were placed inside nanoparticles. If a cancer cell mutates, so does its structure. However, nanoparticles can be structurally redesigned in order to deal with this. Now, while researching nanoparticle variations, I learned of a deadly type of brain cancer, which sadly has no chemotherapeutic solution. However, as a new solution, a nanoparticle chain is being designed, which has a specialized surface that allows it to bond to this specific type of cancer cell. Now, this is already increasing survival rates in animal testing. On top of this, as a solution to the lung cancer variation mentioned earlier, a nanoparticle has been designed that falls apart as a reaction to the cancer cell's acidity. Now, I think that these 2 variations indicate that we don't need a specific inhibitor for every single type of cancer cell. The nanoparticle's capsule alone is what is important. Now, nanoparticles only have a few hurdles to clear before they become fully efficient, which, from the research I've done, I think is very likely. Now, after doing a fair bit of research, you come to understand the common flaws of nanoparticles. Because nanoparticles are injected into the bloodstream, they can often take so long to get to the site of cancer that they will fall apart before doing so. This limits their efficiency, but there are solutions in the works. For example, what's known as hydrophilic polyethylene glycol coating, and boy is that a mouthful, has been developed. This is put on the surface of nanoparticles and allows them to last in the bloodstream for longer without falling apart. Now, on top of this, another experiment includes the use of ultrasound, which is a type of signal, and this is used to gather injected nanoparticles at the site of a tumour. Now, if we can develop these solutions further, I think we can clear any hurdle that stands in the way of the nanoparticle treatment. Overall, due to the nanoparticle's efficiency, room for customization, and potential design improvements, I believe that nanoparticles could become the key to upgrading all cancer cell inhibitors, as well as unlocking the shackles that cancer has placed on so many patients. Now, if you hear about any institutions that are funding further nanoparticle research, rest assured that that is money well spent. If this research is successful, we will one day be able to harm cancer without harming ourselves. Thank you.